Hello and welcome to Core Talks, Core AVI's technical podcast series. Today we're going to delve into the world of SYCL SC, the new safety critical open standards API from the Khronos Group. I have with me here today Neil Stroud, General Manager of Automotive and Embedded here at Core AVI, and Ken Wenger, Senior Director, Research and Innovation. Welcome both.
Hi, Marybeth. Hi, Ken.
Hi.
So to begin, Ken, I'll ask you, can you give us a brief introduction to what SYCL SC is?
Hi, sure. So SYCL SC is a safety critical version of SYCL, and SYCL is a high-level compute API. And the purpose of SYCL is to enable access to accelerators at a much higher level than, for example, OpenCL or Vulkan, where in order to implement compute tasks on OpenCL or Vulkan, you have to have a certain level of specialization and understanding of what the hardware looks like and how it operates. For example, if it's running on a CPU or a GPU, there is some level of specialization that's needed to implement compute tasks in these APIs. With SYCL, the advantage is that you can just write C++ code that gets somehow magically and seamlessly accelerated behind the scene. And so what we're doing with SYCL SC is we're bringing a safety critical version of that high-level API.
So Ken, so why SYCL? What is it about SYCL that we wanted to use as a starting point to go and derive SYCL SC as an industry? Let's start there.
Right. So if you think of compute and the state of compute today, so if you have a problem that you need to solve that requires a high volume of computation, and you need to use an accelerator device like a GPU, for example, there are some APIs that you have available for you. So one of them would be like Vulkan, or you have OpenCL, for example. The problem with these APIs is that they're low level and they're very close to the hardware. So that gives you some advantage, but at the same time, it kind of minimizes the amount of people that are willing or able to go to that level to be able to get that close to the hardware. Some people want to stay much higher level, closer to something like a C or C++ interface. And so what SYCL does is that it enables you to write code that looks just like C or C++ that is accelerated behind the scenes. So you don't have to worry about how the accelerator works. You just write your C++ code and it gets handled by the SYCL implementation. That's really the advantage of SYCL over some other APIs like OpenCL, is that it really brings the barrier to entry to interacting with an accelerator to a much higher level point.
So let's make the distinction between low level and high level, because there's obviously trade-offs there, and I'm guessing it's from a developer perspective, it's a different skill set, because if it's low level, you need to be in the bits and bytes and low level programming, where obviously if you're when you say high level, you're up at a higher level language, like, as you said, like C++. So what are the trade-offs there as we think about those two worlds?
Yeah, absolutely. So when I speak of low level, what I'm referring to is APIs that bring you very close to the accelerator. And when you're that close to accelerator, two things happen. One, you have a lot more control over the performance of the task that you're trying to execute. So you have a lot more control over the accelerator. So let's say it's a GPU. You're able to define how your task runs in the GPU, in what order the tasks runs, and how you parallelize that across all of the GPU's cores, for example. And having that kind of access to a GPU gives you a lot of control over performance as well as resources and resource management. But that comes with a cost that it means you have to have the ability to and the experience to be able to program a GPU in that way. And so it really requires specialization of your, the team that you have that's working on implementing these tasks. And if you're able to bring up your implementation to a higher level, what that means is you want to be able to abstract yourself as much as possible from how the accelerator works, so that it requires less specialization. And so you can expose the accelerator, its engines, to a much wider audience that's not able to specialize to that level of detail. And so that's what higher level means, is you want to be able to give your users the ability to interact with these accelerators without having to understand how they work, and without having to get to the point where you need to be very granular about how you execute the tasks. And so, for example, if you just write, let's say, code using C++, that enables you to write a lot faster, and you have a lot more people that are able to write C++ compared to people who are able to write things like OpenCL. The trade-off is that you get less control over the performance. Does that answer your question?
Yeah, no, absolutely. That's really good clarification. Thank you.
Mm-hmm.
So when you talk about accelerators, you kind of interchange accelerators and GPUs. I guess that's because it's closer to home for us. But I'm assuming SYCL can be used across different compute elements, including CPUs, NPUs. Is that a true statement?
Absolutely. So SYCL is meant to work across any class of accelerator. That's why, as you noted, I kept saying accelerators. I use GPUs as an example.
Hmm.
But SYCL is language that's meant really for any accelerator, CPUs, FPGAs, GPUs, anything that's able to implement the API, which is in the high performance computing market, it's also a lot of different devices.
Okay, so from a scalability point of view, it definitely checks that box by the sounds of it.
Absolutely, yes, and it does that in different ways. So as I said, because it's so number one, because it is meant for different types of accelerators, it lets you scale in that direction. You know, it'll the applications you write on SYCL will work on any accelerator you have on the back end. So it scales in that direction. It also scales in the sense that because it's a high level language, so it requires less specialization about how the hardware works in the back end. You're able to expose the API to a much wider audience. So it also scales from a workforce standpoint as well.
Okay, excellent. So one more question on the SYCL before we jump into the SYCL SC thing. Can you give some examples of applications, use cases where SYCL's being used in the industry today?
Sure. So let me answer this question the following way. So let's say if you think about automotive use case where you want to write you want to implement let's say a computer vision system for self-driving, as an example. There are many different components that you need to have in a system to be able to perform a task as complicated as self-driving. So you have to have the ability to detect objects, right? So you need to have some specialized computer vision mechanism that's able to detect and sense the environment where the vehicle is moving. But that's just one component. And so for something like that, you would use, let's say, OpenVX, which is a safety critical API, or you would use like Vulkan. But that is one component of what a robust self-driving pipeline looks like, because you have your vision system, but then you need to figure out, okay, so once I understand the environment I'm moving in, what is my path planning look like? And what are the decisions that I'm going to make based on the environment that I'm sensing? And so all of these things, they're not we don't have as in the case of computer vision where you have, let's say neural networks, and you have specific libraries that you can use, and specific objects like object detection algorithm or neural networks that you can use to analyze your data. When it comes to path planning and to being able to make decisions about the environment you're negotiating with, you don't have like canned algorithms that you can just plug into. You need to have what we call the glue code. It's basically code that serves as the glue to all of these different structures that you're dealing with, all of these different libraries and tools. And so what SYCL provides is the ability to write general compute code that can serve as a glue mechanism to combine all of the different algorithms and tools that we have available for like a robust vision pipeline, for example. So in which ways are we using SYCL? That's one example, is we can use SYCL to generate the code that enables you to, make a complete pipeline, as opposed to just separate algorithms that are doing specific things like vision and sensing, for example, radar information. With SYCL, you can combine all of those things and implement like a sensor fusion system, for example.
Okay, so let's jump to SYCL SC now. So we know that Khronos, we now have a working group within Khronos that's been tasked with developing the SYCL SC standard over the coming months and years, and get us to a point as an industry with other contributors to the standard to a ratified open API standard. First question related to that is why can't we just use the standard SYCL in safety critical applications? Why wouldn't that work?
So that's a good question. I'll answer it in different parts. So this is not specific to SYCL. Typically, for any sort of, if you think of any system as a stack of different components, right? You have a driver, you have different libraries that perform different tasks, and then you have general compute languages like SYCL. At each level, at each step of your stack, you want to have components that are certifiable in safety critical environments. And the way you achieve that, or one way you can achieve that more easily, is if you choose to implement those components using safety critical APIs. The reason for that is that when you implement or when you develop a piece of software using a safety critical API, the API itself makes certain guarantees that make certification a lot easier. So for example, at the API level itself, we remove things like undefined behavior and non-determinism. Right. So one of the problems with certifying software or implementing software in safety critical systems is that the software has to be deterministic in space and time. So we need to be able to do things like measure and forecast how much resources this implementation is going to require at runtime, and that can change from your worst case estimate. The same thing is true for your execution time. You have to be able to determine worst case execution times so that you can program, for example, your real-time operating system around that. When you have an API that's not safety critical, what happens is the API itself contains components or functions that are not easily implementable in a way that's deterministic. So what happens if you didn't have SYCL SC, for example, and we wanted to make a SYCL implementation safety critical, we kind of have to break from the SYCL standard. We would have to modify SYCL. We would have to change SYCL and remove the things that are non-deterministic in SYCL to be able to certify our implementation. And essentially what that would mean is you have to come up with a safety critical version of SYCL anyway. So that's a reason for coming up with SYCL SC, is to help people that are going through that process, is to say, well, don't do it yourself, and then we end up with an industry that's very fragmented with everybody having their own version of SYCL. Here's a standard way to implement SYCL that is safety critical. And that's true for SYCL as well as Vulkan and OpenGL and any API that we've developed over the years that are safety critical. Does that answer your question?
Yeah, no, absolutely. And as you were talking, I was thinking exactly that. I can draw the parallels between Vulkan and Vulkan SC. Of course, we've got a kind of proven track record in the industry of doing exactly the same thing, of taking an open API standard such as Vulkan and then deriving a safety critical, almost a derivative of that, or which again, as a developer, gives an open API standard that's safety critical, which then has the knock-on benefits that you can scale effectively across multiple platforms within the safety critical domain, and that gives you port of choice and a whole number of benefits, right? So I can absolutely see the parallel between that and SYCL SC. So where are we on that journey? I know from you that we formed the working group, but what does that actually mean, and where to next, and what are the tasks in front of the working group?
Right. So where we are is that, so we spent all of last year in what's called an exploratory forum. So Khronos, which is the organization that puts together all of these open standards, we have a process in Khronos that defines how a new specification is launched or created. And one of the steps in the process is that you have to create first an exploratory forum. And the purpose of the exploratory forum is to do a few things. First is to find whether the industry actually needs what you're proposing. So here we are inviting people from the industry to give feedback and to verify whether what we are proposing makes sense to them. So these are essentially our end users. So that's what we did all of last year with SYCL SC, is we created the exploratory forum where we tried to essentially figure out, does the industry need this? What does the industry think about it? And then the second purpose of the exploratory forum was to come up with an SOW, basically a statement of work for a working group that, once it's created, executes on that statement of work and essentially defines the specification. And so at the beginning of this year, we launched the good news on that was that the exploratory forum was successful. The Khronos board approved the creation of a working group, which means that the industry saw the need for Vulkan SC with great support. And so at the beginning of this year, we created the working group, which now has the SOW defined last year. And the goal of the working group is to now start working on defining the specification. And that's what we've been doing.
Okay, good. So who else is in that working group?
So we've had a lot of great support, as I said, from different industry leaders, including, companies like ARM, AMD, Barcelona Supercomputing Center, CodePlay, CoreVI, Intel, Mercedes-Benz, Intellias, which is a company that works with AutoZar, Qualcomm. So these are some of the names that I have for the members that have explored interest.
Okay.
So
I mean, that's a good strong set of names, right? That to me indicates the level of interest and the need for moving this forward. If there's those kind of names in there, which is good for the standards, good for the industry, right?
And it shows a variance too in the types of industries that we're talking about. We have some in the list that I mentioned. We have implementers, we have end users, we have people working on the device side of things, on the accelerator side of things, on the middleware, on OEMs. It's a very interesting and varied group.
Yeah, absolutely. So as we go down this path, just thinking about the end game, once we've got this standard ratified and we start to see solutions out in the marketplace, so will that SYCL SC implementation stand on its own, or is the plan to stick that perhaps on top of Vulkan SC? What are your thoughts there? What's the working group thinking?
Yeah, so that's a great question, and that's something that we've discussed at length in the working group. So the goal of SYCL SC, I should mention, is to be as close to SYCL as possible. That's something that's very important for the working group, is to make sure that the SYCL SC specification is changed only insofar as the changes are related to safety. Right, so we want to make sure that the SYCL SC and SYCL specification are as close as possible, with the only differences being safety driven. And so SYCL as an API is able to run on any backend, so it doesn't have to have any specific sort of backend implementation behind it. And we want to be able to support that ability on SYCL SC as well. However, because of the safety critical mandate and keeping with the mindset that a robust application for autonomy, for example, requires a full stack of components that all have to be certifiable, we're working towards making SYCL SC implementable on top of Vulkan SC. So that's one of the requirements that we have in the working group that came out of the exploratory forum, is to make it possible for SYCL SC to be implementable on top of Vulkan SC. And the reason for that, I mean, is that it really enables you to build on a stack of open standard APIs that are safety critical.
Okay, that makes sense. Okay, switch gears a little bit. So I've heard in the various conversations that I've been having with industry players, and I have to say there's been an awful lot of excitement around SYCL SC, even though we've only just formed the working group. I think there's a lot of forward-looking excitement when we get to a solution. But one of the things I have heard is that there may be a solution and a path for developers who've perhaps developed in other languages, such as CUDA, to migrate their initial investment, their software investment, their developments via SYCL SC to execute on different platforms and again bring them scale. Is that one of the benefits of SYCL SC?
Yeah, I think so. I mean, SYCL SC, again, the primary objective is to bring a safety critical API that is a high level interface for compute. So if you think of SYCL and you think of CUDA, what they are is they're both high level APIs that enable acceleration of high level code. And again, what I mean by that is code that looks like C++, for example. So they enable C++ code to be executed seamlessly through an accelerator. But both SYCL and CUDA, as we know, the problem is that they're not safety critical APIs. So what we want to do with SYCL SC is bring in a safety critical API that has the same level of access, and then both for SYCL code that is existing today and CUDA code, we want to make it as easy as possible for people to migrate their existing code base from both SYCL and CUDA into SYCL SC.
So again, giving developers port of choice, freedom, the opportunity to pick different underlying hardware architectures based on, I guess, not only based on performance and capability of that accelerator, but also, of course, availability, given where we are in the industry, we're still having supply constraints as well. So that could be another kind of almost side benefit of this approach.
Yeah, I mean, that's actually, I would say more than a side benefit is that's the goal of an open standard, right? Is to be able to enable an industry to build software stacks that are separate from hardware implementations, so that as hardware changes and the landscape of hardware providers changes over time, we want to have our software stack be as decoupled as possible, so they can outlast, for example, trends in hardware.
Okay. All right, so I'm assuming at some point Core AVI will start to develop a SYCL SC solution. Of course, it aligns very, very nicely with our expertise in the safety critical domain. We, of course, have Vulkan SC solutions today. So this, I guess it's no accident, this seems to align very nicely with where we're headed as a company as well. So I know with Vulkan SC, we took a little bit of a risk-based approach and started to develop on Vulkan SC before the final standard was ratified. Do you think we're going to take the same approach with SYCL SC?
Yeah, I think so. Absolutely. I think one of the benefits of working and being part of a working group that's defining a specification is that you get to. It's not, by the way, I would say it's not just a benefit. It's kind of one of the aspects of a working group that has to happen is you have to have an implementation that validates the specification, right? Somebody needs to implement the specification we're working on so that we know that it's implementable. And so we've done that in every SC specification that we've been a part of, and we've done a few at this point. And I don't see why SYCL SC would be any different.
Okay, yeah, and as I said before, we're seeing an awful lot of industry and market interest in this standard. We're being pushed hard to provide our thoughts and feedback on this. And of course, as you said, being part of the working group is a fundamental piece of that as well. So excellent. Okay, I think we're kind of at a point now where we can wrap up. So thanks, Ken, for kind of explaining SYCL SC and some of the questions and the challenges that we're being faced in the industry. And with that, I'll hand back to Mary Beth.
Okay, thanks so much, everyone, for joining us on today's podcast. A special thanks to our guests today, and we look forward to bringing you more technical insights in the next podcast episode in our series. Thanks for listening.